I'm going to go over some notes with you guys for lesson 3-2, unit 3, lesson 2, which is graphing quadratic inequalities. There's a slide I put together. It has a couple of pictures on it that may be helpful. First, I have the quadrants labeled. You might sketch a graph of that for yourself. Just do a little T and label your quadrants 1, 2, 3, 4. We use Roman numerals to label the quadrants. The way you can remember how to number them, which one's first and what order, is you can draw a C around the origin. The way I just used move my mouse like this, and that's how you can remember how to number 1, 2, 3, and 4. I have a couple of examples here of what a quadratic inequality graph looks like. Here, sometimes you shade your inequality inside the parabola, sometimes you shade it outside the parabola. It depends on what the inequality is. I want to make sure that you're graphing an accurate curve and that you use the proper line type, whether it's solid or dashed. Here are some steps for solving quadratic inequalities. Just like when we did linear inequalities, we solve by graphing, really, and the shaded area is your solution. So you may have a quadratic equation in standard form, which is the first example that I put here for you, ax squared plus bx plus c. That's the way your questions were, or that's the way we found equations on lesson 1 when we did regression. Also, you may have a quadratic equation in vertex form, which we haven't really talked about yet. But all of your equations on your practice sheet are written in vertex form. We'll spend more time with that when we do lesson 3. If you didn't get the memo, there are a couple of questions on your first assignment that ask for you to write an equation in vertex form, and I want you to skip those. We'll do that when we introduce lesson 3, so next time. Okay. So your equation may be written one of these two ways. Make sure that you use the proper line type, depending on what your inequality symbol is. We'll use a test point. I'll show you how to do that. And you shade wherever it's true. So if I pick a test point on that, any point that's not on the parabola, and it tests true, then that's where you shade it. If it tests false, then that's not where you shade it. You would shade on the other side of the inequality, or on the other side of the parabola. Whoops. And then we'll list which quadrants contain solutions. I'm going to switch to my document camera so that I can work through some things with you and you can see what I'm writing. So here we go. This is your first example. Y is less than 2 times x plus 1 squared minus 1. First thing I notice here is I have a less than symbol. So I'm going to use a dashed line when I draw that curve. Now I need to figure out what points are going to define this parabola. So go to your calculator and you can type into y equals the equation as if it was y equals this 2 times x plus 1, close parentheses, squared minus 1. Okay, now I'm going to look at the graph first so that I can figure out where on the table I need to look to get my exact points. And it appears that my vertex is here where x is -1. And then the y, the little tick marks for the y's are very close together. So I'm just going to look at the table where x is -1. Okay. So here where x is -1, y is -1. That will be my vertex. I can verify that this is the vertex also from the calculator, because you can see that on either side of this negative 1. The y values match because it's a symmetrical graph. So I'm going to, you can make a table and write them out if you want to, or if you just want to put your marks on your graph, that's fine with me. So I'm graphing -1, -1, -2, 1, 0, 1. You need to have at least 3 points to graph an accurate curve. There are more points. I'm going to use 5 on this one because it'll fit-ish. This graph that I printed just goes up to 6, but since my next point out from the on the curve is -3, 7, I'm just going to kind of draw that here. That's close. And then 1, 7, just to get a good idea of the shape of this thing. When I draw the curve in, I need to make sure I use a dashed line. Okay, this is my inequality, or my parabola. To finish solving, I need to determine where to shade my graph. So I'm going to pick a test point. I'm going to pick 1, 0. To use a test point, I plug in for x and y into my inequality and see, is this true? So I need to know, is 0 less than 2 times 1 plus 1 squared minus 1? This is my x for my test point. This is my y for my test point. So I need to know, is 0 less than 2 times 2 squared minus 1, which is 2 times 4 minus 1. 8 minus 1. Okay, is 0 less than 7? Yes. So here where my test point is, that's true. So 1, 0 is a solution. So that tells me that everywhere actually on that side of the curve, the same side where my correct test point is located, everywhere out here is also a solution. So my solutions are everywhere outside of this curve. Then I told you we're not going to use domain and range to describe this. We're going to list the quadrants where I have solutions. The solutions are the shaded parts. And in this case, I have solutions in all 4 quadrants. 1, 2, 3, 4. Here, another example. Y is greater than or equal to 2x squared plus 12x plus 21. This time, since I have greater than or equal to, I'm going to use a solid line when I draw that curve. Let's put this in our calculator. And see where our vertex is and get us a couple of points. Okay, I'll look at my graph first to see where on the table I'm going to look. It appears that my vertex is where x is -3. I look at my table. When x is -3, y is 3. And then I can check and make sure that on either side of that, my y values match going out away from that. So that is indeed my vertex. I'm going to graph -3, 3. And I can also graph -4, 5. And -2, 5 for this one. And the next point out from on my curve is going to be at 11. It doesn't fit on my graph, so I'm just going to use the 3 for this one. When I draw this, I use a solid line because or a solid boundary because I have greater than or equal to. I'm going to pick 0, 0 for my test point. So my question then is 0 greater than or equal to 2 times 0 squared plus 12 times 0 plus 21, because I'm plugging in 0 for x and 0 for y. So I got is 0 greater than or equal to 2 times 0 squared is 0. 12 times 0 is 0. Is 0 greater than or equal to 21? Well, no. So my test point this time is not a solution. Since it's not a solution, that's not where I shade my graph. I have to shade my graph on the other side of the inequalities, or the other side of the boundary. So my solutions will be everything on the inside of the parabola this time. And by the way, my solutions are greater than the vertex here. This always works like this. So if you're not big on doing a test point, if you find the vertex and sketch your graph, your inequality symbol will show you which side of the parabola to shade. So here, since I have greater than or equal to, greater than in this case is inside. Here I have less than, because the way the parabola is turned is outside. And here, quadrants. My solutions are in quadrants. You always have at least 2 quadrants for your solution. It'll always be the one that you see and the one beside it where the arrows on the edge of the parabola where the arrows are. I'm saying that because this, you assume that you have an infinitely large graph. So if this were bigger and bigger and bigger, it would eventually come over into the first quadrant. So my solutions are in quadrants 1 and 2 in this case. Even though when you first drew it, it appears that they're only in 2. They're actually in 1 and 2. For my last example, example 3, I would like for you to write this down. Go ahead and work it out for yourself. So pause this. Go ahead and work it out for yourself, and then you can turn the video back on and watch me work through it. I just want to verify that if you try on your own, you're able to do this, and we'll agree on the answer. And then you can turn this back on and check yourself. So go ahead and get started. I need to know the rest of the vertex. You have 4, 1. Verify that that is in the middle of the y values. It is. Get a couple more points for myself. I'll draw this curve with a dashed line. Since I have a greater than. And since I have a greater than, I know, because I know the way this works, that my solutions will be greater than my vertex. So outside the parabola in this case. But I'm going to go ahead and do a test point before I go coloring everything in, just to make sure. So I just plug in for x and y, is 0 greater than negative 0 minus 4 squared plus 1. That's my question. So is 0 greater than negative 4 squared plus 1? This is 16. So negative 16 plus 1, that's negative 15. Is 0 greater than 15, or negative 15? Yes. So 0, 0 is a solution. That goes along with my solutions are everything greater than the vertex. So I can shade this in now. Everything then outside the curve will be a solution. The last part is to list which quadrants contain solutions. And whenever you have a curve and you shade outside, you're going to have solutions in every quadrant. So that's how I list it. 1, 2, 3, 4. I do have a check yourself key in Canvas. It's not completed because instead of a quiz for this assignment, I have you guys entering in what you got, what your answers are for the different practice problems that you're doing. So you can do that as a quiz twice, so that if you make any errors, go back and review what you typed in, review the graph that you have, and correct anything that you may need to correct, and then you can enter that in again. Let me know if you need any help. You can email me or send a note on Remind 101, and I will answer back. Thanks.